This video is on quality control temperature data. This is the 7th in the R-Instat series on climatic analysis. The data are now tidy and defined as climatic. The graphs in the Check Data menu have been used. The graphs provide an overall impression of the data quality. A single dialog is R-Instat's main tool to support the quality control of the temperature data. The methods in this dialog are based on those in an R package described in a WMO meeting in 2013. The R package is called R-Climdex Extra QC. In R-Instat, some checks, like detecting duplicate dates, were discussed in an earlier video. Here, we show how most of the remaining tests have been implemented. Data for illustration are from Sadore in Niger. They are in the R-Instat data library. They are from 1983 when the research center was established and include temperatures and rainfall. In the QC temperature dialog, the fields fill automatically. If this is not the case for your data, then either you are in the wrong data frame or your data were not defined as climatic. You can do all the tests together, but the results are usually clearer to interpret and use if done one at a time, which we show here. Start with an overall range test. This gives a new data frame with just the days that are outside the limits. There are 203 days like this. Looking more closely shows that many of these days are from values of T-mean that are just over the 30-degree. Sadore is quite a warm place. Delete this data frame and return to the dialog. Change the limit of 30 to 35 degrees. Aha! 10 rows. That's more useful. Close the output window to look at the results more clearly. It can be useful to see the values for other elements on these same days, but here there are too many, and so we delete them. Right-click on the element after T marks and click on Delete Column. Do the same for the rest of the columns. T-mean is only true on one occasion. It has a value of 0 on 7th October 2001. The other 9 oddities are for T-marks. There are 6 zeros and 1 day with -9. And these are obviously wrong. We need to see the high values of 50.5 and 54.4 in context before deciding on them. We'll show later how to do that. Back to the dialog for the next test. Untick those options. Tick the next. Change the 4 to 5 and press OK. Wow, there's 103 days to examine. Delete the extra variables as before. These 6 consecutive days had the same value of 40.2 degrees for T-max. That's pretty surprising. Even more curious is the fact that 19.6 degrees on 5 consecutive days with T-mean overlap with this same period in March 1997. These first rows were in 1997, and that is also useful information because it shows this sort of repetition never occurred in the years from the start in 1983 to 1996. About half the 1 or 3 days were within roughly a year from October 2006 and then particularly in 2007. These included an amazing 12 consecutive days when Timin was exactly 19 degrees. It is also odd on that occasion that Tmax and the rainfall both seem plausible on those days. The next test is called jump. That's when there is a large change in either variable from one day to the next. The R-Climdex QC package uses 20 degrees as the limit, but we find smaller jumps are still worth investigating. Change the default of 10 degrees to 12 and try. This time, there are just 36 rows to investigate. It is really less because 24 are the oddities we saw earlier with values of 0 or -9. There were 6 zeros for Tmax, one day with -9 and 1 0 for Tmin. Each gives 3 rows for these jumps, so that accounts for 24 of the 36 oddities. The other oddities are usually in pairs. Timin jumped from 15.7 to 27.8 degrees in December 1995. It is often useful to see this in context. It looks as though 27.8 is probably an error. Perhaps it should have been 17.8, and this could be checked against the original data. We find that jumps like this in Timin are often likely to be mistakes. However, similar jumps in Tmax are sometimes because that day was rainy. The first observations in Tmax are a drop from 40.2 to 28.2 degrees on consecutive days. Here, we see a drop in Tmax associated with the rainfalls on 3 different dates. What is a bit surprising is that in the case with 40.2 dropping to 28.2, the rain was on the hotter day. Was it maybe recorded on the wrong day? The fourth check examines the differences between Tmax and Tmin, checking when it was strictly smaller than 0. There are just 8 days to examine. However, 7 of them are the instances of 0 or -9 in Tmax that we know about already. So, the difference in August 2006 is the only puzzle. Looking in context shows it is probably a problem with the value of Tmax rather than Tmin. Check that maybe it should be 34 rather than 24. There is one further check in this dialog. It shows the dates from boxplot outliers that we examined graphically in the previous video. Even changing the outlier criterion from 1.5 up to 3, there remain 29 values to investigate in more detail. Before being concerned that this is too much work, please reflect that this is just 29 days from over 12,000 and is for 2 elements. So that is only about one number per 1,000 values to investigate. For illustration, we examine the first 2 oddities. In October 1983, the Timin value of 9 degrees does seem too low and should be corrected or set to missing. In contrast, in late October 1986, Tmax was surprisingly low, but the same day was also surprisingly rainy. In addition, the soil temperature at 1 p.m. was also measured and was low. So this is probably a genuine value. The next video is on the quality control of the rainfall records. There, we also discuss what to do next with the oddities in the data. There is also a supplementary video on quality control for other elements.